Hello everyone, welcome back to my channel. So in the previous video we saw the different types of AVL rotation that we can do. There are four different types of AVL rotations, that is LL, RR, RL and LR. So we have discussed about these rotations in the previous video. In this video we'll see how to insert the elements in the AVL trees, okay, and how to keep balancing the trees in between, right? So AVL tree, as I already told you in the previous video, that it is very similar to a binary search tree. So the insertion also goes along like a binary search tree, and then you keep balancing. So after you insert every element, you have to check the balance factor of each and every node, and you have to see if the balance factor does not lie between -1, 0 or +1, then that means the tree is not balanced, and you have to balance it now by performing those rotations. So this is what happens in insertion part. So now let us see how to do it. So the first element here is 21. So let me just put 21. Okay. Now there's only one element. So of course balance factor is 0 right now. There's nothing to check over here. Now the next element is 26. 26 will come onto the right side of 21. Just like how we do insertion in our binary search tree, like that we are doing over here. So 26 is coming onto the right side. Now you can see here that the balance factor is still balanced right now for both of them, because for 26 the balance factor is 0, and for 21 it is 0 minus 1, which is -1. So it is still balanced, right? So the balance factor is okay, fine. So 26 done. Next is 30. 30 will come onto the right side of 21, and when you go on to 26 it will come onto the right side of 26. So that is how we will be inserting 30. So 30 will be coming over here. So I hope you all know about the fact that when we are inserting the nodes, so the node which is having a higher value than the root node will come onto the right side, and the one which is having a lower value than the root node will come onto the left side. So here, since 30 was a larger value than 21, it came onto the right side, and then we had 26, and 26, for 26 also it is a larger value, 30 in comparison to 26. So it again came onto the right side. So 30 insertion is done. Now comes the time when we have to check the balance factor once again. So the balance factor, always whenever you're putting the balance factor, go from bottom. Okay, don't go from top, start from bottom. So the balance factor for 30 is 0 because there is no left or right subtree, it is a leaf node. In case of 26, the balance factor is 0 onto the left side, there is no nothing on the left side of 26, and minus 1 onto the right side of 26 because 30 is there onto the right side of 26. So which is -1. -1 here is the balance factor of 26, and as in case of 21 we have 0 onto the left side and 2 onto the right side, so -2 becomes the balance factor of 21. So this is how we found out the balance factor. Now you can see here we got a -2 over here in our balance factor, which means the time has come to balance this tree. So how to balance it? First we need to check which type of rotation we have to perform. So if you can see here, things are going onto the right side. First onto the right side of 21 we have 26. Then again onto the right side of 26 we have 30. So there are two R's over here. That means we have to perform RR rotation over here. And in RR rotation, what do? We turn the whole thing in anti-clockwise direction. Okay, we turn the whole thing in anti-clockwise direction in case of RR rotation. So how are we doing it? This whole thing will be turned in anti-clockwise direction. Now I already told you how to do these kind of rotations in the previous video. In case you haven't seen it, if you see this video also, you'll be able to understand. So there's nothing to worry about that. So when I perform anti-clockwise rotation on this, what happens is 26 will come onto the top. Okay, it gets pulled onto the top. 21 will be going onto the left side, and 30 will be coming onto the right side. Okay, so this is how you perform your anti-clockwise direction rotation. Now check the balance factor once again. The balance factor is 0 because leaf nodes, and then 0 here as well because one on left side, one on right side. So 1 minus 1, 0. So now you can say that yes, the tree is balanced. So the insertion of 30 part is done and the after balancing part is also done. So now the time has come to insert the next element. The next element is 9. So now how am I supposed to insert 9? Okay, let me insert it bottom over here. So we have 26, we have 21, 30, and now we are going to insert 9. So 9 is less than 26, so it will come on to the left side of 26, and then it is again less than 21, so it will come on to the left side of 21. So we'll be inserting 9 over here. Okay, so we have inserted 9. Now check the balance factor for this. So balance factor is 0 for 9, 0 for 30, both are leaf nodes. For 21 it is plus 1 because 1 onto the left side. And for 26 it is 2 on left side and 1 on right side, so 1. So 1 is the balance factor for 26. So right now the tree is balanced. So now we can insert our next node. So we have inserted 9, the next node is 4. So 4 will also come onto the left side of 9 because 4 will be less than 26, so it comes onto the left side of 26. Similarly, it is less than 21, less than 9. So it keeps coming onto the left side and gets attached at the bottom. So we have inserted 4. Now again we have to check the balance factor. Balance factor of 4 is 0, of 30 is 0. For 9 it will be 1 because 1 on the left side. For 21 it is 2, 2 onto the left side. Okay, so here and then for 26, how will the balance factor will be? It is 3 onto the left side and 1 onto the right side. So 3 minus 1, 2. So again we got a 2. So now you see we have two 2's present over here. That means it is unbalanced and we have to balance it. So we'll go from bottom and we'll try to balance this. Okay, so first let me balance this part. Okay, always try to go from bottom in these kind of trees, AVL trees. So first let me balance that part, okay, where the balance factor is coming to. So if you see, 9 is going on to the left side of 21 and 4 is also going on to the left side of 9. That means we have two L's over here. 2L means we have to perform LL rotation. And in LL rotation, we turn the whole thing in clockwise direction. Okay, we have to perform LL rotation and we'll turn this whole thing in clockwise direction. So how am I going to turn it in clockwise direction? Now when I take this part and turn it like this in clockwise direction, see how the tree is going to become. First will be 26, 30 will be attached as it is because I'm not changing anything onto the right side of 26. On the left side, I'm performing clockwise direction rotation. So 9 will be coming onto the top. 9 gets pulled onto the top. It gets attached to 26. And 21 will be pulled down, coming onto the right side of 9. And 4 will be as it is onto the left side of 9. Okay, so when you perform clockwise direction rotation on this is how your tree is going to look. Now check the balance factors. So balance factor for the bottom ones are 0. For 9 also it is 0 because 1 on left side, 1 on right side. So 1 minus 1, 0. For 26, what is the balance factor? Now here a lot of people get confused because there is 3 nodes on left side of 26. So what a lot of people do is they think that 3 is the height of the left subtree in 26 and they do 3 minus 1, which is 2. No, this is wrong. This is not the correct way of doing it. You cannot assume the left subtree height as 3 over here. You have to take the longest subtree in the left side. So if you have multiple branches, take the longest path. How are you supposed to remember if you have multiple branches onto the left side or right side? Then try to take the longest path till the leaf node. So I can take either this part, okay, and consider my height of left subtree as 2, or I can take this part and consider the height of left subtree as 2. So either way, the height of left subtree of 26 is going to come out as 2. So how you're supposed to do is you're supposed to take the longest path and go till the leaf node. That is how you will be finding out the height of the left and right subtree. So in this case, the height of left subtree in 26 is 2 minus height of right subtree is 1. So 2 minus 1 is 1. So now you can see that the range of balance factor is correct. So the given tree is balanced. So the insertion part is done for 4 as well. We have inserted 4 and we have done the balancing thing over here. Now time to insert the next element, which is 14. Okay, now where to insert 14? Okay, let me write this whole thing again. So this is what we got just now. Okay, this is the exact same thing which I wrote over here once again. And we were supposed to insert 14. So how to insert 14? Come from top. First you can see that 14 is less than 26. So it is going to come onto the left subtree of 26. Then the next node is 9. Now 14 is greater than 9. So come on to the right side of 9. Then you have 21. So 14 is less than 21. So come on to the left side of 21. And this is where 14 gets attached. So now that we have attached 14, time to check our balance factors. So balance factor for bottom ones is 0. Okay. Balance factor for 21 is 1 on the left side. And then balance factor for 9 is 1 on the left side and 2 onto its right side. So 1 minus 2, which is minus 1. And balance factor for 26 is, now how did I ask you to find the balance factor for 26? If there are many branches, look for the longest one. So this is the longest branch, okay, that is covering maximum nodes and it is going to leaf node. So the height of the left subtree in 26 is 3. 3 minus height of right subtree is 1, which becomes 2. So 2 is the balance factor of 26. So now you can see we have got the balance factor of 26 as 2, which means it is unbalanced. So time to perform a rotation on this. Now, since the 2 balance factor is coming on 26, so from 2 you have to check which type of rotation you have to perform. So from 2 you can see we are going on to the, the highest, that is the largest path is onto the left side of the subtree, right? So from 2 we are going on to the left side and then we are going on to the right side. Okay, first we are moving on to the left side of 9 and then we'll be going on to the right side. Here I'm assuming the longest path over here, the longest path that we considered for the finding the height of the subtree, right? So this is what we got. Now I'm trying to balance this part. So we have one L over here and one R over here, which means I have to perform LR rotation over here. And in LR rotation, first you perform RR and then you perform LL. And in RR, we are going to do anti-clockwise. In LL, we are going to do clockwise. Okay, and we are going to perform this rotation on which part we will be performing it on this part. Okay, on these 3 nodes, that is 26, 9 and 21, we will be performing this rotation over there. So now we are going to, now I'll tell you one trick also to solve this because sometimes people get confused. So I'll tell you one trick how to do it. So before we go on with our trick, first let us go by the convention method and then I'll tell you the trick. So first we have to perform RR rotation, that is the rotation of anti-clockwise direction. So in this 9 and 12, you have to perform that anti-clockwise rotation. So I'll turn that whole 9 and 12 thing in the anti-clockwise direction. So when I do that, what will happen is we have 26, 30 onto the right side as it is. Don't touch 30, it will remain as it is. Now when I'm performing the anti-clockwise direction rotation, 21 will directly get attached over here to 26 and 9 comes on to the left side of that. Okay, this is how we perform an anti-clockwise direction rotation in this kind of subtree, right, which is in the form of LR. So this rotation we know. But the main doubt comes is how to attach this 4 and 14 after performing this RR rotation. So you can see the bottommost node over here is 9. So check those locations of 4 and 14 in terms of 9. So if you see from this tree, 14 was coming onto the right side of 9, okay, on the right subtree. So attach 14 on the right side and then 4 was coming onto the left subtree of 9. So attach 4 onto the left subtree, okay. So with this you have done your RR rotation. Now one thing is left, which is your LL rotation, that is you have to turn the whole thing in clockwise direction. So these 3 nodes, that is 26, 21 and 9, we have performed the anti-clockwise rotation. Now time to perform clockwise rotation. So clockwise rotation is it will turn this side. So in that what will happen is So after performing that rotation, what is going to happen is 21 will come at the top and then 26 gets pulled down. Okay, and 30 is coming onto the right side of 26 as it is, and on the left side you can see of 26 we have 9, and there are 4 and 14 attached to that. Okay, so this is what happens when you turn this whole thing, which you can see over here, in clockwise direction. When you turn that whole thing in clockwise direction, this 26 gets pulled down, 21 will get pulled up, and 9 will come onto the left side with its attachments, and you have 26 and its attached node, that is 30 over there. Okay, it's child 30 over there. So this is how you perform the rotations. So now LL is also done, RR is also done. So now this LR rotation is done. Now if you check the balance factor, the tree will be balanced. See, let me show it for you. We have 0, 0, 0 as the balance factor. 0 is the balance factor for 9 as well. Then we have 0, minus 1. Minus 1 is the balance factor of 26. In case of 21, we have 2 minus 2. That is 0 is the balance factor of 21. So this tree is balanced. So this is how you perform LR rotation. Now remember that I told you I'll tell you a trick to perform this LR rotation. So if you're getting confused in performing these two steps one by one, there is a trick also to perform this. So let me tell you that trick. So here, as you can see, while performing the LR rotation, we selected 3 different notes, that is 26, 9 and 21, and we were going to perform this rotation on these 3 notes. So the trick is, first you need to write these 3 nodes in ascending order. So 9 comes first, and then we have 21, and then we have 26. Okay, this is how you write the ascending order, right? Now check for the medial element over here. So the middle element is 21 over here. Okay, now try to make a binary search tree such that 21 is at the middle, and the left element will be 9 and right element will be 26. That is, whatever comes as the middle element, make it the root node, and then take the left and right subtrees. So if 21 is the middle element, it is very obvious that 9 is less than 21, so it will come onto the left side, and 26 is greater than 21, so it will come onto the right side. So make a binary search tree like this, with 21 in the middle and 9 onto the left side and 26 onto the right side. Now after you do this, the rotation part is done. Okay, you're done with your rotation. Now just attach the leftover nodes. So how are you going to attach the leftover nodes? You have 4, 14 and 30 left. Now see its connections. 30 was attached onto the right side of 26. So just attach 30 onto the right side of 26 in our final tree as well. And then as for 4 and 14, 14 was coming onto the right side of 9. So attached 14 onto the right side of 9, and 4 was coming onto the left side of 9. So put 4 onto the left side of 9. So that's how we got our tree. So if you see, both these trees are equal. Okay, so instead of performing all these 2 steps, you can just perform this trick and you can directly write off your final tree after the whole rotation thing. So you can remember this trick if you're getting confused. Otherwise, you can just go step by step. Alright, so we are done with this part. Now we have inserted our element 14. Now there is one element left to insert, which is 28. So let us insert the element 28 in this. Now this was our tree, which I just wrote once again, and we are supposed to insert 28. So 28 is greater than 21, it will come on the right side. It is greater than 26 as well, it will come on to the right side of 26. But it is less than 30, so it will come on to the left side of 30. So this is how I have inserted my 28. Now after inserting, time to check my balance factor. Go from bottom. The balance factor for the leaf nodes are 0. Balance factor for 30 is 1, because 1 onto the left side. Balance factor for 26 is 0 minus 2. So we have minus 2 as the balance factor. Now balance factor for 21 is 2 onto the left side, that is, take any longest subtree. Okay, so 2 onto the left side and 3 onto the right side. So minus 1 is the balance factor for 21. Okay, so 2 minus 3, that is minus 1. So now you can see here that we have got a unbalanced row here because of that minus 2 present over there. So time to perform the rotations over here. So since I have got minus 2 over here, from 26 I will start seeing which type of rotation I have to perform. So from 26 go bottom and see on which side the nodes are attached. So first the node is attached on the right side of 26 and then it is attached onto the left side of 30. So first we are going on to the right side, then we are going on to the left side. So we are supposed to perform RL rotation over here. So in RL rotation, first we'll do LL and then we'll do RR. LL is nothing but clockwise direction, RR is nothing but anti-clockwise direction. And we will be performing it on this part. Okay, that is 26, 30 and 28. On that part we'll be performing this rotation. So first thing is I have to perform the LL, that is the clockwise rotation. Now when I do the clockwise rotation, how will it happen? So when I turn this whole thing in clockwise direction, 30 will get pulled bottom and then 28 gets attached. So what happens is 21, now left side will be as it is. There is nothing to touch over there. Don't try to mess with the left side because it is completely okay. On the right side you have 26 and then when you perform LL, that is clockwise direction rotation, this 28 gets attached directly and 30 will come onto the bottom. So you have performed the clockwise rotation on this part. Okay, so the clockwise rotation side is performed. Now time to perform the RR rotation or the anti-clockwise rotation. So clockwise is done. Now for anti-clockwise rotation, you need to turn this whole thing in anti-clockwise direction. So when you turn that whole thing in anti-clockwise direction, what will happen is 21 as it is, we have our 9, 14 and 4 as it is. Here what happens is if I am doing it in anti-clockwise direction, in RR rotation, 28 will become as a root node for this 3 and then 26 gets pulled down onto the left side and 30 will come onto the right side. So this is how you perform your RL rotation. LL is done, RR is done. Check the balance factors. 0, 0, here also 0, here also 0. 0 for 9 and 28 also, and 0 for this part also. So this part is done. This is how we perform our RL rotation. Now do you remember the trick which I told you for your LR rotation? Writing in ascending order and then drawing the binary search tree? That same trick can be performed for RL rotation as well. How are we going to perform it? We know our 3 elements that we have chosen, 26, 30 and 28. Write it in ascending order. So first comes 26, then comes 28 and then we have 30. Right? Now we just have to put 28 as my main root node and then attach the rest over 2 elements, that is 26 onto the left side because it is less and 30 onto the right side because it is more. So I've performed the RL rotation on this part. Now I'm just going to attach my leftover elements. The leftover elements were 21 and the other things. So 21 will get attached, okay, as it is 9, we have 14 and we have 4. So this part of the tree was left untouched, it was as it is, but onto this part of the tree we performed this trick for performing RL rotation. Okay, so you can either go by the trick or you can perform these 2 methods, but I suggest you to go by the convention method step by step. It helps you to clear a concept. But in case you get stuck somewhere and you're not able to understand the rotations, then you can perform this trick and you will be getting the same tree. Okay, so this is how you perform the insertion of elements in AVL trees. If you still have any doubts, you can let me know in the comment section below. So thank you for watching and meet you in my next video.